Today's math strategy video is on graphing points in the coordinate plane. Okay, so what we're going to do in today's lesson, we're going to take everything that you've already learned about the coordinate plane, graphing, creating ordered pairs, and we're going to do all of those together. But now we're going to add the piece of, we're going to talk about what an equation would look like for, that would represent all of these models. So we are going to look at our example problem here. It says Gabe has $8. He goes to an arcade where each game costs $1. Use equations, a table, and the coordinate plane to represent the relationship between how many games Gabe plays and how much money he has left. How many games can Gabe play if he wants to have exactly $2 when he leaves the arcade? Okay, so I'm always going to fill out my table first when I have a question like this, or I end up having to plot points, make an equation, all those things. I'm going to do the table first because I feel like it's the easiest. So Gabe has $8, and then each game costs $1. So here's our information that we need. We will come back and talk about this question after we have done, we filled out all of our models. So here's our table. The X is going to represent the number of games played, and Y is going to equal the amount of money left. Over here, you can see on your coordinate plane, here is your X-axis, games played, money left is Y-axis. So that's what we're going to represent right here. Now, if Gabe walks in and he has not played any games, hasn't played any, 0 games, how much money does he have? Well, he would have $8 because he hasn't spent any yet. Okay, if he plays 1 game, he would have $7. Okay, 2 games, $6. 3 games, $5. 4 games, $4. 5 games, $3. 6 games, $2. So remember that this represents our money. This represents our games played. Okay. So now what I'm going to do is I'm going to complete the ordered pairs where X is the games played and then Y is the dollars left. So if I am going to just write this up here because it doesn't include that, but 0 and 8. This would be an ordered pair right here. So we have 1 game, so $7 left. 2 would be $6 left. 3 games, $5 left. 4, $4 left. 5 would be $3 and 6 would be $2. Okay, so now I can take these ordered pairs and I can find the location on the coordinate plane. So we have, if he played 0, remember this is our origin. It's like kind of our starting point, but we're not always going to have to plot a point here. So in this case, we will not be plotting a point, but it is important because we do have this value right here. So if he played 0 games, he would still have $8. So I'm going to plot a point right here. Okay. Now, if Gabe played 1 game, he has $7. 2 games, he has $6 left. 3 games, $5. 4 games, $4. So you kind of see a pattern here. And if he played 8 games, he would have no money left. He would have $0. So something that you can notice is that we aren't connecting these dots, but it is going down. So why, first off, do you think that these points are decreasing? Why are they decreasing? So they're decreasing because he is spending money. So he is every time he plays a game, he loses $1. So it goes down. So because this represents the money being lost. Each of these represents taking $1 away. Taking $1 away, taking another $1, another $1, and another $1. Each time it represents $1 being lost. So Now let's look at this and let's think about how we can write an equation that would match this. Okay, so if we had, if Gabe had $8 in each game, here this would represent the amount per game and then the number of games and then how many dollars he has left. So you can see here that we play number of games, so one game, so we had $8 minus, so it's 1 times one game, so that would be 1, so that would be 8 minus 1 equals 7. 8 minus $1 times 2 games is 2 equals $6 left. We have 1 times 3, so this would be $3. So 8 minus 3 would be 5, and so on and so on and so on. So what do you notice? What is changing in these equations? What's changing? Okay, the number of games is changing and the dollars left. The dollars left are changing. So if I was going to write an equation for this, when a number changes, I need to have that be represented with a variable. Because if I have now remember a variable is like x. Any number can be substituted in for this. So x could be 1, x could be 2, it could be any number. I can substitute any number in for it. So if I was going to write this equation, I could say $8, because that's what I started with. Okay, and then remember that when we do things in parentheses, those are the operations that we need to do first. So each game costs $1. So if I did 1 times, let's say, I'm going to make a big X because X is number of games. So if I substituted any of these numbers in, I would get dollars left. What do dollars left? What represents that? If we think back about on our X and Y axis, what represents money left? Well, that's our Y value. So equals dollars left, or it can equal Y, because Y is also changing. This right here, this changes each time because the number gets less. So altogether, 8 minus 1 times X equals Y. So if I substitute it, let's check this. Let's check this equation right here. Let me write it up here where you can see it in this orange. Let's say that let's use this. Let's put 3. So we're going to substitute 3 for X. And what should I get? My answer should be 5, okay? So I have 1 times 3 is 3, and 8 minus 3 equals 5. And 5 is the answer there. So if I substituted any of these values in this equation, I would get Y. I would get the corresponding ordered pair as my answer here. So that is the end of today's math strategy video.